Hey Opties! Today we're looking at bisectors and we're going to do some practice. So we are given an image for our practice with segment bisectors. Our image has some given information. Point P is the midpoint of segment S and line L passes through point P. So because of this, we know that line L is a bisector. Because it passes through the midpoint, that is telling us it cuts segment S into two equal-sized pieces, or two congruent pieces, or two congruent segments. Let's draw our tick marks, or our congruency marks. So just two different ways of saying the same thing. That tells us that segment AP is congruent to segment PB. So let's write that as well. AP is congruent to PB. Notice I am putting the segment bar on top, and that's because I am referencing the actual object. I'm not talking about the measure or the length of these segments. I'm referencing the object. So anytime you're talking about congruent, you're talking about the object itself, and you can do the lines. I also remember this because I'm thinking, well, there's an extra little line on top of the congruency mark, and that goes with the extra line on my segment. Let's take a look at number 1. It says find the length of segment S. So that's our goal, find the length of the entire segment S. And we're given that line L is a bisector of segment S. Good, so we kind of already figured that out, but it gives it to us as well. The length of segment AP is 12 units. Okay, so if AP is 12 units, that's 1/2 of the entire segment S. So there's two ways we can solve for this. Let's do one way where we're talking about AP and PB. So one way is to say that AP plus PB equals AB. And this is just a general segment addition approach. That would tell us that AP is 12, and since PB is congruent to AP, that's also 12. So that would equal AB being 24 units. So that's one way, and that's a segment addition approach. Let's do a second approach. So we know that AP is half the length of the entire segment S, or segment AB. Again, AB is the same as segment S, so when I wrote that here, even though it says to find segment S, they're the same thing. So just to be clear there. So we can also say this, 2 times AP is equal to AB, or segment S. This is also segment S. Okay, so 2 times AP, well, AP is 12. So AB is 24 units. So we have the same answer for two different methods, which we should because it's the same problem, same length we're trying to find. So same answer, but just two different ways to think about it. Either the segment addition, where we know that the other segment, PB, is equivalent to AP, or we're doubling that bisected segment, the piece that is half the length of the entire segment length. Let's take a look at number 2. Find the length of the segment formed by point P and an endpoint of segment S. So this is asking us to find the length of AP or PB, and it really doesn't matter because they're equivalent, or they're congruent. Their lengths are equivalent and the actual segments themselves are congruent. So let's look at our given info. We see again that it tells us line L is a bisector of segment S, and the length of the segment S is 3x plus 10 units. The length of segment AP and segment PB is 2x plus 1. Okay, so let's work this two ways, or let's set it up two ways, and if we work it two ways, we're going to be doing the same thing anyway. So I'll show you two setups and then we'll just work it one way. For our first approach, let's think about segment addition. So AP plus PB equals AB, which is the same thing as segment S. So AP and PB are both 2x plus 1. So we could say 2x plus 1 plus another 2x plus 1, because they're both 2x plus 1, equals 3x plus 10. Okay, so there's one setup, and then we could solve that equation. Another setup, thinking about it as the segment AP or PB being half the size of the total segment. So if it's half the size, you can also double it to get to the full segment length. So we could write it this way. 2 times 2x plus 1 equals 3x plus 10. Notice these are the same equations written differently, because 2x plus 1 plus 2x plus 1. Well, those are two of the same thing being 2x plus 1. So this 2 times that is the same representation. So two different ways to write it, but it's essentially the same thing. I think I will prefer to do number 2's thinking, so let's go ahead and just solve this one. Now let's keep in mind our end goal is to find the length of segment S. So once we find the value of x, we have to substitute back in for the expression for segment S, which is 3x plus 10. So let's not forget to do that. So let's look over here. We're going to distribute our 2. So 2 times 2x is 4x. 2 times 1 is 2. And that equals 3x plus 10. Let's maybe subtract 3x. That will be a 0 when we subtract 3x from both sides. 4x minus 3x is 1x. We still are adding 2 on the left-hand side of the equation, and we're equaling 10. One more step to find x, subtract 2 from both sides. And x is 8. Okay, so one more step. Let's come back over here. I know we're kind of going a different part of the page, but that's okay. We want to find the segment S, which is also what we're calling AB. But I'll write it both ways. Segment S, which is AB, equals 3x plus 10. So let's substitute. 3 times 8 plus 10. 3 times 8 is 24 plus 10 is 34. And that's going to be units. So we're done for finding the length of segment S. So here are our steps. Set it up. It could be segment addition, or it could be 2 times one of the smaller chunks equals the total if it's bisected, right? Then you solve for x, and if you're trying to find a segment length, you substitute back into that expression to find the length. So 3 main steps there. Now let's do some practice with angle bisectors. We have an image, and we're given the information that the measure of angle B is equal to the measure of angle C. So let's write that out. The measure of angle B equals the measure of angle C. Now, if we know this, we also know this. Angle B is congruent to angle C. And you can write it with the angle symbols and not the whole word angle. So taking away the measurement is how you would talk about just the angle itself and not its measure. And that's what you'll write when you do congruent. You wouldn't write the measure of angle B is congruent to the measure of angle C. You'll just write angle B is congruent to angle C. Okay? Let's take a look at number 3. Find the measure of angle B. Okay, so that's our goal. Find the measure of this angle. Given, right R is an angle bisector of angle A, which we knew because of the given information here, but they're going ahead and telling us here as well. The measure of angle A is 70 degrees. Okay, so if we want to find the measure of angle B, we know that angle B is half the size of angle A. So let's write that out, and then we'll substitute to actually get our numerical value. There's two different ways to look at this. One, the measure of angle B is half the measure of angle A. We can also say this. The measure of angle A is 2 times the measure of angle B. Two different ways of representing it, but they mean the same thing. So let's substitute into both. The measure of angle B is what we want to find. So we're going to take half the measure of angle A, which is 70 degrees. So that's going to be 35 degrees. So the measure of angle B is 35 degrees. Let's do it this second way as well. The measure of angle A is 70 degrees. So it's got to be equal to twice of the measure of angle B. Well, we would have to divide both sides by 2 because the measure of angle B is just a variable. And half of 70 is 35. So two different ways to think about it, two different ways to solve, and either way works. Our last practice problem is number 4. Find the measure of angle A. So we're finding the total angle this time instead of one of the pieces. We are given that ray R is an angle bisector of angle A, and the measure of angle A is 8y plus 10 degrees. The measure of angle C is 5y minus 3 degrees. So let's set it up two different ways, and then we'll just solve one way. So it's the same idea as up here because B and C are congruent angles. So we can substitute the measure of angle B for the measure of angle C. So the measure of angle C is 1/2 the measure of angle A. We can also say that the measure of angle A is 2 times the measure of angle C. So now let's substitute. What is the measure of angle C? That's 5y minus 3. And that's half of 8y plus 10. Let's write it this way as well. Measure of angle A is 8y plus 10. And that's 2 times the measure of angle C, which is 5y minus 3. Now make sure you put 5y minus 3 in parentheses because it's 2 times the whole thing. If you didn't put parentheses, then you would have only had a 10y and you wouldn't have ever gotten the negative 6y, and it would be wrong. So you just have to decide which would you rather do. Would you rather distribute 1/2 or distribute 2? In this case, either one is going to be just about the same amount of difficulty because 8 and 10 both are divisible by 2, and you can always multiply by 2. So it just depends on what you want to do. I think I will do this one because I'd rather get down to smaller numbers. So let's work on this one. Again, they're the same. You're going to get to the same answer. Let's do this one though. So 1/2, we're going to distribute that. 5y minus 3 remains on the left-hand side for now. What's half of 8? Well, that's just 4. So 4y. Half of 10 is 5. So notice I've got smaller numbers. I would be getting to 10 and negative 6, which aren't huge numbers or anything. But if you're just getting smaller, just maybe a little easier to deal with. We can subtract 4y from both sides. And that's a 0 right there. And 1y on the left-hand side. And we still have the minus 3. And that equals 5. One more step into solving for y. Add 3 to both sides. And y is 8. Now, we're not done. What's our goal? Keep your goal in mind. Make sure you answer the question. We want to find the measure of angle A. So we have to substitute our y value. So the measure of angle A is 8y plus 10. Now let's substitute. We know what y is, we just found it. So 8 times 8 plus 10. 8 times 8 is 64. And 64 plus 10 is 74. And this is an angle, so it'd be 74 degrees. So the measure of angle A is 74 degrees. All right, that is it for bisectors practice. See y'all next time.